live events, yeah, I have my mom connecting and send some messages online. Oh, that's my boy.
Yeah.
André, começar no... Just a moment, Erik. André, começar em ponto, certo? Tá. Quando for 5 horas, eu vou começar, então. Faltam 10 segundos. 10 seconds to start, Erik.
Okay. And then I'll start with sharing my screen, or do I wait until you tell me to do so?
Yes, I will tell you. I will just speak of 1 minute or 2.
Okay.
Okay, now we are live. Welcome for the last day of LuxOUG Virtual Tech Days. Thank you so much for joining us today and on the previous days, if you had the chance to join us. We also record the videos on YouTube. You have a chance to revisit those, and also today we will do the same thing. We will record the videos of the presentations. In fact, we are streaming online, so you can also follow on YouTube. So a little bit about us, LuxOUG. We are founded in 2019 with a couple of friends. Here, based in Luxembourg, we are more than 100 registered members on the portal. If you are not registered there, please do it, because it's a totally free membership. We have a lot of content regarding Oracle stuff, about engineering system, cloud, a lot of good content on the portal. We already delivered 7 previous webinars before LuxOUG event that happened this week. So the board member of LuxOUG, it's André Ontalba, Carlos Magno, Fernando Simon, Leonardo Lopes, and then me, Rodrigo Mufalani. So now I will pass the word, the control to Erik, our first speaker for today. And we will also have later on Mohamed Uri, Yves Ravikumar, and Lonika Dickmans. Okay, so Erik is with you right now. I will stop sharing my screen and you can share yours.
Okay, there it is. I hope you can see it.
Yes,
yes.
But there is a bar, a black bar close to the right side. Maybe it's the resolution of the monitor. Maybe it's too high.
Just a second.
Okay.
I might be sharing the wrong one at this moment. I think I might be sharing the wrong screen at this moment.
Now I am seeing the presentation, but it's cut off.
Oh, okay. Sorry.
No, it's okay.
I hope everybody has some time, because
no big deal.
Let's see. This is that one screened. 2. That is the one I need to share.
Okay.
Is this better?
Let me see. Erik Ivan. Okay, now it's perfect. The resolution.
Okay.
It's perfect.
Then all that is left to become perfect is the presentation itself. Okay, welcome everybody. Really enjoy that you've come here. I don't know what it's like where you are, but where I am at the moment, it's about 30 degrees Celsius outside. So I think it's awesome that you took the time to see this presentation, even though it's such nice weather. This is what you're here for, the handling errors during bulk DML operations. And this is me, is the least interesting slide. I used to be an analyst. I used to work in laboratories, microbiology, biochemistry. I worked with Oracle since 1995, not with the company Oracle, but with Oracle technology. And I'm self-employed since 2009. I mainly work within database, SQL, PL SQL, stuff like that. And I play around with Apex, but I do not dare to call myself an Apex developer. Well, data migration projects are the main thing that keeps coming back in my career. And since 2 weeks ago, I'm an Oracle ACE. Before that, I was an Oracle ACE associate. If you would like to become an Oracle ACE as well, I suggest you just Google for Oracle ACE program, and you will soon get to a page with all the information that that is available about that. Yeah. Let's go to the presentation itself, because I have a lot to show you, a lot of slides. The background of this talk, like I said, I did a lot of data migrations, and when you do data migrations, you often have a hell of a lot of data to handle, and you want to do that in a very short amount of time, the least amount of time possible, because when you're busy, the databases will not be available for the business. So you want this time to be as short as possible, but you also want control over what you're doing. So usually you still want to do it within PL SQL and not just with single SQL statements. That's why I often use bulk processing, and that's when you also run into errors and you need to handle them. In this presentation, if you see a bar like this, it points to a script where some code is in that you can run yourself. When I deliver this presentation to Luxembourg to be downloadable, then I will give these scripts as well. So you can run it for yourself if you want to. You don't have to type it. Some of these scripts need some objects, and these will be created by this create demo objects script. One of them is a table with which I fill with 20 times the contents of the customers table, leading to 1.1 million rows. And when you're done with everything, you can run this cleanup script, and all the objects will be thrown away again. So, bulk operations, why? Because row by row is slow, and single SQL statement is blazing fast. So why bulk operations? Why not always single SQL statements? Well, row by row gives you full control over just about every bit that comes along while you're processing it. Whereas single SQL statement, well, if it gets complex, you can run into a situation like this, trying to control all this data that comes along, and especially when it's complex, when some rows need to be handled just a little bit different than others, then you often need the row by row, or at least the procedural processing of PL SQL, which will be leading to row by row. And bulk operations, well, they are not the fastest, because that is a single SQL statement, but it is pretty fast. And you still have the full control. Now, how fast is bulk fetching? Well, you probably already know this because you're interested in error handling doing this, so you probably have worked with this before. But if you do a slow by slow or a row by row fetching, I did this on this table that I mentioned before, then it takes 5.3 seconds to finish. If I do the exact same thing but with bulk collects, then it only takes 0.7, so that's about a factor 7. And that's awesome. When we do the same thing with data manipulation, normal would be a normal for loop and just doing it row by row, and it takes 80 seconds to finish. If I do it with a for all statement, then it is down to 13 seconds. And this is, yes, this is great news if you want to not spend too much time on your on the running of your scripts. But what if this happens? There's always this one row or this small group of rows that just does not behave the way the rest does. We have to handle that. So we have to handle the errors. And during bulk fetching, well, we are out of luck. There is no bulk error handling for bulk fetching. But that's usually not where the errors happen. So it's not too much of a problem. During bulk data manipulation, we have by default no exception handling per row. And we have no way of doing a save point to roll back to before this one row failed. We do have save exceptions and log errors, which basically says that no exception handling per row is not true anymore. I will talk about save exceptions and log errors in length for the rest of this presentation, so be prepared to be bored. Save exceptions. It saves your exceptions. It makes sure that your exceptions don't get out of the statement. It saves the exceptions until the statement, the for all statement, is completely done. How do we do this? Well, just add save exceptions and you're done. When this is added, all exceptions will be kept until the for all statement is done, and then you will run into an ORA 24381 exception. That sounds as if this is of no use because you're still getting an exception. But because of this exception, we can handle the fact that not all rows were successful. Now we can go to the exception handler and we can define we can use the pragma exception init to give a name to this exception, and then we can handle it in the exception handling just like any other exception. And when we get to that exception, then we have a Pseudocollection available. It's called SQL% bulk exceptions, and it contains all the exceptions that occurred while doing this, this bulk processing. According to the documentation, it is like an associative array. Well, that's true. It's not really an associative array, but it behaves like an associative array on most levels. So it looks like an associative array. It smells like an associative array. Let's just pretend it's an associative array. It has two attributes, error index and error code. The error index contains the number of the DML statement that failed. And it is important to remember that it is the number of the DML statement that failed, not the error index that you would expect if you look at the name of this attribute. I'll come back to that later. And it contains the error code. Unfortunately, not the error message, but the error code. And I'll come back to that as well later. If we handle these exceptions, this is what we could do. In this exception handling, we can loop through this collection. Then we can get the error index and the error code from that collection for a certain exception that occurred. And then with these the index and error code, we can do whatever we want. Here I just put it on screen, but we could also go back to the original collection and find out which row exactly it was that went wrong. And this is the output of this script here. Notice the error code is a positive number. It's not a big deal, but it's something you have to be aware of when you want to find out what the error message was that belongs to this number. And we may lose some information because we only have the error code. And yeah, we can look up what message is connected to this number. But yeah, we don't have the exact error message that occurred. So for example, this one, the check constraint violated. Usually it tells you which check constraint. Now, if the table has 50 check constraints, you're out of luck. You're just going to have to go through all of them, see if there's anything that you may have violated. If you have sparse collections, then we get to this point where error index isn't really an index. It's the number of the DML statement that failed. So for sparse collections, the error index is not the index of the record that failed. Error index means it's the, if error index X means that it's the Xth record that failed. We'll try to visualize that. Here we have a sparse collection. There are empty or non-existent rows for index 2, 3, and 5. And if index 4 and 7 should cause an exception, then your pseudo-collection with the errors would contain this. Error index 2 and 4, because it is the second and the fourth row that caused an exception. And this is a bit of a shame as well, because it means that you can't just get exactly to the right spot in this collection, the original collection, to the row that caused the error. You have no index of the row that caused the error. There are a couple of solutions. None of them are nice, but there are a number of solutions. Obviously, you can loop through the original collection and count the rows that you see until you reach the record that is the same number as the error index. Obviously, you can make the dense collection sparse, and you can also do avoid sparse collections, and I will show you all of these solutions. The count solution is basically simple. You get a bulk exception error. In this case, it's number 2. You go to the collection, you start with your first record, you check if that is the second record. Well, obviously it isn't. So we go to the next existing record and we increase a counter. Is that counter number 2? Yes, it is. So this is a record belonging to this error, this exception in the bulk exceptions. So we can handle the exception for this row. Then after handling that exception, we go back to the bulk exceptions. That's one says that the next one is number 4. We go back to the collection. We were at row number 2. So we go to the next existing row, it's number 3, that's not 4. So we go to the next row, that's 4. Ah, that's the one. So we handle the exception, etc., etc. Pretty simple. But well, the disadvantage is that you have to go through an extra loop through the collection. But you only have to do that if there actually are exceptions. If there aren't, then obviously you don't have to do this. And that's something you have to keep in mind with all of what I'm showing you. The exceptions are, well, the name already says is that are exceptions. You shouldn't have, normally in a normal situation, you shouldn't have too many exceptions. Your SQL bulk exceptions should contain relatively few rows. The other solution, make dense. In that case, we have a collection that is sparse, and then we can just go into the collection, first row, then we check if a row with an index +1 exists. In this case, it doesn't. So we go to the next available record. We copy that to this empty spot, and then we delete the original records. This is what we repeat until we've done all rows, and we have a dense collection that we can process. And now any error in the error collection will have an error index that is actually an index. The disadvantage is you have to do an extra loop through the collection to make sure that it's dense. And you either have to do this always before processing the collection, or you just accept that it's dense, you process it, and if there are exceptions, then you go back to the collection, you make it dense, and you can get to your records again. Use status solution. There we add an extra column to our collection with either status or action or whatever you want to call it. And while processing the data before we do the for all statement, we don't throw away the records that we don't want, but we put in a status that it's not okay or that we have to reject it. Then when we process the collection in the for all, we can do a where clause that says where status is okay or action is processed. The disadvantage here is that these rows still lead to a DML statement. It still leads to your insert, your update, your delete, whatever. It won't do anything because the where clause isn't met, but still there are a number of rows where there is a statement that needs to be processed. If you have a lot of those, then that's going to take considerable time. Okay, so now we've seen what this save exceptions can do for us for one table. It's fine. But is your database as simple as this? One table? Well, maybe not. This is more what I see when I do, for example, data migrations. We do multiple for alls. We want a number of clients to be inserted in one bulk. But the clients also have subscriptions. The subscriptions have deliveries and returns. We have a tree of tables that we want to do in one transaction with multiple clients. And if anything goes wrong, then we need to handle that for that specific client subscription, whatever. Oops, yeah, inserts, and then an error occurs somewhere in the tree. And with data migrations, often you want a tree for a parent to be complete or not there at all. So suppose something goes wrong with a return, then we don't want incomplete data after the migration. So we want then the entire client to be removed from this migration. But we already did the bulk processing for the clients, for the subscriptions, for the deliveries, and then for the returns, and then suddenly we run into an error. that means we have to do some cleanup. These are all the other returns of the client need to be deleted. The deliveries of this client needs to be deleted. The subscriptions need to be deleted, and the client needs to be deleted. Well, option 1 to do this is make use of the foreign key option of Cascading Delete. That is a very powerful thing. In that case, all you have to do is just delete the client the data belongs to, and the entire tree is deleted. But it's usually not an option for live databases. This is fine if you're doing a process that you have the database for yourself. But if it's live, then usually you don't want to change the foreign keys to Cascading Delete, because that could lead to severe problems. And it only works if you actually have foreign keys between the tables. Some of those tables may have a relation, but not foreign keys between them. And I admit, then you probably have a bad data model. But yeah, sometimes you're not in a position to change that. Sometimes you just have to work with that. And then you just can't use the Cascading Delete. And the logging of the extra rejections are hard, or maybe even impossible. The extra rejections, I mean, sometimes, often during data migrations, you will want to log that some data was in fact correct, but you couldn't insert it because of an error in one of the other records of the same client. This logging is pretty hard if you do cascading deletes. Another option is to add the primary key of the parent to each collection. Then for each bulk exception, you determine the primary key of the parent. Oops. And then you delete all rows of that parent primary key in the table where this error occurred. Then, if the parent has other children, you also delete the entire tree below that table. Then you delete the parent record. Then you determine if that parent has another parent. And then you go through this again, etc., until you get to the topmost parent. And this gets really ugly, really fast. You don't have to have a very huge tree for this to be completely unmanageable and not understandable anymore. So I don't think it's a really good option, but it is an option. There's another option to create metadata connection, and usually I use this one. You create an extra collection, and I like to do that, to make that a nested table so I can fire queries on it. In this extra collection, you map the index of each row in each collection in the tree to the primary key of the top level parent. And if a record causes an exception, you can easily get the primary key of the top level parent from that metadata. And then you can get all the rows that have the same top level primary key. And you can just delete them. This is what it could look like, a nested table that has a table name. That's the table for which a certain record is in a collection. A collection index, that's the index number where you can find this row in the collection. The top level PK, that's the primary key of the top level parent. And a table PK, that's the primary key of this record in this table. Then we have here an example with this metadata table. We see that there are records for the collections for the table clients, for the subscriptions, and for the deliveries. The collection index is the index in that collection with this data. Then we have the top level primary key. We have client ABC and client KLM. Subscriptions, 3 of them belong to ABC, 1 to KLM. Deliveries, 2 to ABC and 1 to KLM. And then here we have the primary key of this client record, and here the primary key of this subscription record, etc. Now, if, for example, delivery number 2 would run into an exception, then we can easily find to which top-level primary key it belongs by querying this nested table. Query it where table name is deliveries and collection index is 2, and we know the top-level primary key is ABC. Then we can query that table again, the nested table, to get everything that is connected to this top-level ABC. And that's that. And then we have 3 primary keys here for 2 tables. Well, in fact, 4 primary keys with 4 tables, but 2 that we should delete. And we can do that with a simple statement. We can do this in code. We select from the nested table where the table name is returns and the table PK is this one. That's the one that was an error. Then we join it to itself over the top level primary key. And we limit the output to the, for example, the subscriptions table. Then we have a list of primary keys for the subscriptions table, and we can just delete from the subscriptions table. It's as easy as that. Okay, then now for something completely different. Well, we're going to log errors. It's another way of trying to handle errors. What is it? It's a DML statement clause. You just can add it to any DML that you can think of. It logs errors in a separate table, and it has this structure: 5 columns that are always there, or an error number, or an error message, or an error row ID, or an error op type, and or an error tag. And apart from these 5, it has the columns that need to be logged. By default, all the columns in the original table. It's available since 10.2, so it's been around for a while. And the columns to be logged are maximum length character. That used to be varchar2 4000. Nowadays, it could be 32K. Why is it always varchar2 or raw? Well, it's basically because if you have an error in a data type while you're doing, for example, an insert, and you want to log this error, and this column, the corresponding column in this table would be the same data type, then inserting into the log errors table would lead to the same error. And that's not what you want. So you have a very generic data type for all the columns in this table, so that whatever you try to put into the original table, you can put it in here so you can see what error that you made. The creation of the log table, you can do that either manually, just write a create table statement, or you can have Oracle do it for you. If you do it manually, obviously you have to take care that these 5 columns that I showed you are in there, otherwise it won't work. But it's possible to just do it just manually. If you let Oracle do it, then you get to this this statement, DBMS error log create error log. It has a couple of parameters, and this procedure will create a table for you. The only parameter that is mandatory is the DML table name. That is the table on which you are going to perform DML that you want to be logged. All the other ones are optional, and we will go through what they mean. Again, like I said before, if you're using extended table types, then those the columns in this table will be varchar2 very big. And that may not be what you want. And if that is true, then I suggest that you create your tables manually and not not using this this procedure. The parameters, the error log table name. Well, if you don't supply a name, then the name will be ERR $_ and then the table name of the original table. If this gets too long, then it is truncated. So before 12.1 to 30 characters, 12.2 and higher to 128. The resulting table name can't already exist, obviously. If it does, you run into an error and you have to think of some other name. But you can supply any name you want here. I think it's a good idea to have some sort of standard here, so you can recognize the error, the table as an error table. But you can name it whatever you want. The error log table owner and the error log table space. Well, it's just the owner and the table space where the table will, the log table will be created. If you leave out the owner, then it's going to be the current user. And the table space, if you don't supply that, then it will be the default table space of that user. And then there's skip unsupported. If your table contains columns that are not or not yet supported, well, probably they will never be, but okay. Then if you do skip unsupported true, then the table will be created, but those unsupported columns are not in there. They will not be logged. If it's false, which is default, then the procedure will raise an exception or 20069, and you will not be able to create that table. And it's a good thing that that is the default, because if you just try it with the defaults, at least you are aware of the fact that some columns cannot be logged with log errors. What are the unsupported data types? Well, basically this: long, lob, b file, and well, things like nested table, an object, stuff like that. How do we log it? Well, you just add the log errors clause to the end of your DML. You do it like this: log errors with optionally into log table name, optionally a tag, and optionally a reject limit, which means that log errors is all you have to add to your DML statement to make use of this. But you probably will want to give some extra information here. The into log table name defines in which error log table the errors will be logged, because you can have multiple log tables on your table. Or you could have just one, but you invented a nice name yourself, and Oracle will not be able to determine which table that might be. If you leave it, if you don't supply it, then it will use the same convention that was used with the procedure we saw earlier. So ERR $_ with the original table name attached to it. The tag, it's a value that will eventually end up in the ORA-R tag column in the log table. And if you don't supply it, it will just be nil. And it's there so you can identify the rows so you know that this row belongs to this statement. You just have to be creative with what you put in that tag. We'll come back to that a little later as well. The reject limit. If more errors occur then the reject limit, then the statement will fail. So this is a way where you can just accept a certain number of errors, but if you're doing a DML statement over 500 million rows, and once you reach 1 million errors, then maybe there's something seriously wrong and you want it to error out before it runs all weekend and then tell you all 500 million rows were in error. That's a nice way of doing that. Usually in a more or less finished product, you would probably say reject limit unlimited, because you want the entire statement to be processed and then figure out what went wrong. But that would be at the stage where there are few errors. Default is 0, so if you leave it out, then one error is enough to make the statement crash. The error will be logged, but you will not go any further than one error. The statement could look like this: just an insert statement into some table, and then we do a log errors into error $_some table. I add a tag my insert. It's not a very sensible tag, because my colleague might think, I will use my insert as well. But okay, for now, that's okay. I'm doing a tag my insert and a reject limit unlimited. What are the advantages over save exception? Well, we've seen it. It works for each and every DML statement. It's not just for all, but for any DML you do anywhere in your code, in SQL, in PL SQL, anywhere. And we have the entire error message. That's a lot better than just the error number, because we don't lose any information that is in that error message. And we can just log every value of every column, and not just as we try to insert it, but as it is being inserted into the table. Suppose you have a trigger that changes some of the data, or adds data to some other columns or whatever, then what is logged is the result of that trigger. What is logged is the data as we try to put it into the table, not as we put it into our statement. And that is an advantage to us, I think. There are a couple of things you should be aware of. There is no automatic cleanup of the log table. So if you don't do anything, the table will grow and grow and grow, and it will just be huge. Also, this means that old errors with a tag that you used at some point might contaminate your query of the log table if you use that tag again. You might think that your statement just had 500 errors, but 400 of those were from last year when you used the same tag. You can have multiple error tables on one table. I said that before, and that could be just what you want, but it could also lead to tens of tables for logging errors, because every developer thinks, I need a log table, so I'll just create one. I think you need to have some standards in your organization of how to deal with these log errors. When do we create a log error? What will be the naming convention, etc., etc. The error log table is just a single table. There is no relation between that table and the data table, other than the relation that you know that it is used to log errors from that data table. But in the database, there is no relation whatsoever. So you can drop or alter or do whatever you want to one of those tables, and it has no effect on the other table. It will only affect your logging. Sorry, I just lost it for a second. You can only identify the errors that happened for a certain statement by tag. So this tag needs to be well thought over. You have to have sensible tagging so you can be sure that when I query this logging table, I will get the errors that happened for this exact statement. The log table is not session specific. You could make it session specific by making it a global temporary table. I'll come back to that again later. The structure of the log table, well, you have to keep it in sync with your original table. You have to do that yourself manually because, like I said, there is no relation between the tables. If it's not being kept in sync, then you won't get any errors, but yeah, you might not have everything logged that you expect it to be logged. The logging is obviously committed in an autonomous transaction. That is very good, that's very great. So whatever happens to your processing, the log will still be there, unless of course you had a global temporary table. And the statements will always complete successfully, unless of course you go past the reject limit. But if you don't, then your statement will always be successful, no matter how many errors there were in there. So to know whether or not it was completely successful, it is up to you to query the log error table. If you don't, you will just continue thinking everything was okay, but maybe half of your rows were rejected. So do not forget to query your log table and to check if errors occurred. As I said, the log table can be a global temporary table. Then you have to create it manually because the procedure Oracle supplies is not going to do that for you. And it must be an on-commit preserve. Well, obviously, because if you do a commit in an autonomous transaction and you do not have on-commit preserve, then the row will be gone the second you insert it. So the advantages of a global temporary table, well, there are quite a few. All the logging that you see is yours. It's from your sessions, from nobody else. So whatever tags somebody else is using, it won't bother you. There's obviously a default cleanup at the end of the session because global temporary table will be emptied. And the table can be truncated whenever you want during your session and nobody will be bothered. It's just yours. There's also a disadvantage. If an error really needs to be preserved, if you want the errors to be available for you next week, or maybe just tonight, then you will have to manually insert the errors that you find in your log table to some other table, and that's an extra step. Identification based on tag. I've said it a couple of times now, but it's because I really think this is a bad thing about the log error table. It should have done a better job in identifying to which statement a logged error belongs. The procedure, if you use a procedure name, well, it's going to be the same in the next call, even if you have a global temporary table. So you know that if you're looking for this procedure name, it's your call to the procedure name. It's not enough because if you call the procedure twice, then you will have the errors of both calls to the procedure having the same tag. The session ID, well, session IDs are being reused. So even if you do not have a global temporary table, then session IDs, yeah, they are being reused. So you can have problems there. Date time strings, they sound nice, but in a multi-user environment, other people may be using the exact same date time string as a tag. So it's not a good option either. What I often do is create a sysGUID, use sysGUID to create a global unique identifier. and use that as a tag. And then I have a global unique identifier for every transaction. When I start a transaction, so after each commit, I will generate a global unique identifier, and I will use that as a tag until I do another commit or rollback. So what if the two tables are not exactly the same, the log table and the original data table? Well, there are a couple of options. The columns are added or dropped from the original table. The order of the columns could differ, or the column in the log table is too small. Well, in the first case, you have no problem whatsoever. If you have extra tables in your log table, that's no problem at all, because the data from the data table will be logged and the other columns will be ignored. In fact, this means that you could make this table even better for yourself by adding some columns like username, date logged, whatever. You can add whatever you want and just put a trigger on the table to populate these columns. Oh, yeah, and if you have columns missing, I forgot to say that, if you have columns in the log table missing, columns that are in the original data table, then that's not a problem either. It's just that these columns will not be logged. If the order of the columns differ, no problem at all. I didn't expect that, but I had to check it, so it's not a problem. And if the column in the log table is smaller, then you do have a problem. Because if the data that is being logged doesn't fit in that column, well, just like any other table, you will just error out. What if we have the same situation as before with multiple statements? So multiple tables in one transaction, we do multiple bulk operations. There it is again, the clients, the subscriptions, the deliveries and the returns. We do an insert, an insert, an insert, and an error, and then another insert that leads to an error. And then with the error in the returns table, we can just get the foreign key out of the error log table. With that foreign key, we can do a query to get the primary key of the top level parent. And then we can just delete everything below that primary key in the subscriptions and the deliveries and the returns. So that makes it a lot simpler than we saw with the save exceptions options. Delete it. This one I have stolen from Tim Hall, Oracle base, because why would you invent something if you can steal it? He did a test of 100,000 rows, and he tested the performance on several versions of the database. He tested it with the error logging and with for all statements, with save exceptions. And the logging, he did it with a normal insert and with an insert as append. And what we see here is that the error logging is before 12.1, it was really slow compared to the others. Error logging with an insert append was fast enough. That was great, but without the append, a normal insert or other DML would be very slow. As we can see that in 12.1 and further on, that problem has been resolved, so the performance is not really something to worry about too much. The summary. Well, log errors gives the actual error message. Save exceptions, well, you lose information. Log errors also stores actual data. Save exception only has pointers to the collections where the original data was, and you have to try and go find your data. Errors logged by log errors is persistent as long as you don't use a global temporary table. But for save exceptions, after your procedure is finished, the save exceptions are gone as well. Log errors can be used for the ultimate bulk operation, a single statement, and you can't do that with save exceptions. That can only be used for all statements. Save exceptions, correcting your executed DML in a tree of tables that could get pretty complex, but with log errors, it's just a couple of extra DML statements. It's a lot simpler. With log errors, you always have a successful statement as long as your number of errors is below the reject limit. So it's up to you to check if anything went wrong. Save exceptions will just raise an exception that will notify you of the fact that something went wrong. And log errors makes you work to identify the errors caused by the last statement. Save exception only has the errors for the last statement. So you don't have to worry about, are these errors my errors? They are. They can't be anybody else's. And before 12c, well, the performance of the log errors could be bad. And that's it. And I have about 5 minutes left. So I'm not too, oops, sorry. This is the one. So, questions. Do we have questions? Let's.
Time for questions. Thank you, Erik, for the amazing presentation. I will start with one question from me.
Yeah.
What's your, because I used to work as a DBA for a long time.
Yeah.
And what's your approach to help developers to follow these good practices that you present today?
Well, just kick and hit them if they don't.
That's a good one.
No, it's just a matter of good upbringing, I think. Being a good parent, telling them that they should do it, and not just to tell them that they should do it, but also why. Most developers, I know that DBAs think differently, but most developers are not there to make your life hard. They are there to do their job, and they have an assignment from their client or their employer, and the employer wants something done, and they go and do it. If what they do is eventually making life hard for other developers or for the DBA, then this should be communicated to the developers. And a good developer, a normal developer, a developer as the ones that you may expect them to be, will listen to you and will listen to your arguments of why he should do things differently or shouldn't do things. And he will try to comply. And a developer that doesn't, well, that's the kind of developer that you really should try to lose, because those are useless in any way.
Yeah, thank
you.
So
I think it's just a matter of communication, telling them not just to do this, not give them a book full of rules. This is how we do things over here, but tell them why. Tell them that if they don't, people, or maybe they themselves, will get into trouble.
Yeah, I faced one similar situation in the past, but regarding performance. And since I started with doing some internal presentations and tell them how to analyze our execution plans, some stuff like that, as you said, collaboration, communication, the performance of the database was really good after some month, for example.
Yeah, and usually the developer is happy if the performance is good as well. So if you can change their behavior, making the database perform better, be more reliable, be more safe, that is an advantage for the developer as well. So
Yes.
I think developers and DBAs really should learn to.
Yes, we cannot touch their code. We just can work together to
exactly
be more.
We have different responsibilities, but in the end, we are all there just to make the company prosper and to make the company make money, so we can still be employed and just go on with what we're doing.
Yeah, sure, indeed.
That's the ultimate end goal, and it's the same end goal for both DBAs and developers.
Sure, and by the end, everybody will be happy.
Exactly, exactly.
So we have also a greeting from Amit on YouTube channel, and
okay. Yeah.
No more questions.
No more questions. Then either I have been very clear, or nobody cared, or everybody has fallen asleep, or
No, I don't think so. I think our presentation was really, really good. Yeah, and I would like to thank you so much for presenting on LuxOUG.
Okay, thank you very much for having me. I really enjoyed being here, and I'd like to be back.
Very nice.
Okay.
So now we will have